Hello everyone, I am Divyan Singh, a student of Civil Engineering third year at Khwaja Moinuddin Chishti Language University. Here, I represent a presentation which focuses on expensive soil and their engineering problem. First of all, we see the table of contents in this introduction, definition of expensive soil, mineralogical composition, expansion mechanism, appearance, identification of expensive soil, occurrence in India, engineering problems, treatment and preventive measures, case study, conclusion, and references. First part is our introduction. Expensive soil are special clayey soils that undergo considerable volume change when water content changes. When water enters the soil swells. When water evaporates, it shrinks. This continuous swelling and shrinkage leads to cracks, settlement, and structural damage, and making them problematic for civil engineers. Expensive soil are widely distributed around the world, particularly in arid and semi-arid region. Then, what is our expensive soil? That is basically known as black cotton soil, swell, shrinkage soil, and cracking soils. Expensive or swelling soils are that type of soil that swell when absorb water and shrink when lose water. Only certain clay are expensive, mainly those containing montmorillonite component. Then, mineralogical composition. The expensive behavior of soil mainly depends on its mineralogical composition. The clay mineral are as follow. First is montmorillonite. Montmorillonite is most common mineral in expensive soil. Extremely high swelling potential, weak interlayer bonding, that type water easily enters. Found in bentonite, black cotton soil, and many arid and semi-arid region. Second is our allied component, that is of 2:1 clay mineral like semicide. Potassium ion partially locked togetherly. Limited water enter compared to semicide. Third is our kaolinite, that is of 1:1 clay mineral. Strong hydrogen bonding between layers. Minimal interlayer swelling. Then expansion mechanism. Expensive soil are made of small negatively charged plates. When water is added to these expensive soil, the water molecules are pulled into gaps between the clay plates. As more water is absorbed, the plates are forced further apart, leading to an increase in the soil pressure or an expansion of the soil's volume. Then, appearance. Soil containing expensive clays become very sticky when wet, usually are characterized by surface cracks or popcorn texture when dry. The presence of surface of cracks is usually as indication of an expensive soil. Then identification of expensive soil. Identification of expensive soil can be done by mineralogical identification, physical properties, visual identification. Then occurrence in India. Expensive soil cover about one-fifth part of India. They are mainly found in regions formed by volcanic basaltic rocks, widely distributed in central and southern India. Major states are Madhya Pradesh, Maharashtra, Gujarat, Andhra Pradesh, Tamil Nadu, and Rajasthan. These states have large black cotton soil deposit, creating construction challenges. Then, engineering problems: foundation heave, differential settlement, cracks in building, reduction in bearing capacity, problems in road and pavements, damage to underground utilities, problem in canals and embankments, effect on light structures, economic and serviceability problems. Then, treatment and preventive measures. Treatment measures: soil stabilization, on which lime stabilization, cement stabilization, fly ash stabilization. Moisture control, replacement of expensive soil, in which we can replace the soil by sand, gravel, moram. Then pre-wetting of soil and use of chemical additives, on which calcium chloride, sodium silicate, potassium salts. That is preventive measures by using proper foundation design, proper good drainage, control vegetation near structures, use of sand fusion, structure measures, plinth protection. Then is our case study on which location place Nagpur, Maharashtra, soil type black cotton soil, structure single story residential house, foundation type shallow strip footing, soil characterized at site, high clay content, liquid limit 60 to 70%, plasticity index more than 35%, presence of montmorillonite mineral, free soil index about 70 to 100%. Problems observed. After 2 to 3 years of construction, the following defects are noticed: cracks in wall and floors, uneven settlement of foundation, door and window jammed, uplift of floor during monsoon, tilting of boundary walls. Causing of failure. The main reasons of failure were seasonal moisture variation in soil, use of shallow foundation on expensive soil, no soil stabilization done, poor drainage system, trees, plant close to the building, causing moisture imbalance. Conclusion and references. Here, conclusion: expensive soil cause serious engineering issues. Problem identification is very important. Suitable foundation and stabilization method can reduce the damage. Essential for safe and economical construction. We take references from K.R. Arora and Gore, that is of soil mechanics, B.M. Das sir, principle of geotechnical engineering, IS codes to expensive soil. Thank you.